Hi, 8th grade. This video goes with lesson 8.5 covering variation functions. For the sake of condensing a little bit of our material and just since we're trying to virtually learn this, I've decided to only do half of this lesson. If you are moving on to geometry next year, it is going to be important that you take some time to go back and read through all of the notes so that it at least looks familiar. But for the sake of this video and your assignment, we're only going to be focusing on two types of variation. That's going to be direct variation, which you have learned in the past. We just haven't used that terminology a ton, as well as inverse variation. And apparently Augie's wanting to get in on this lesson, so I will try my best to talk louder than him so you can hear me. I have a note here to recall from pre-algebra. We learned the equation y equals k times x. We learned that all the way back in 6th grade, chapter 3. And what that did is that represented a proportional relationship where k is the constant of proportionality, or you might remember the phrase being straight line through the origin. So we've been doing this. This is essentially just a line that goes through the origin. And the reason why we learned it as k first is going to come back to us today with direct variation. K is just the slope of the line that goes through the origin. It's essentially the same thing as y equals mx plus b, but your b is going to be 0 through the origin, and they're giving your slope a special name of k. So the only time you'll ever see it written as a k instead of an m is if it goes through the origin. And that's supposed to be a nice hint to you that it is a proportional relationship that goes through the origin. If we're thinking word problems, that means your initial value is at 0. So for example, let's say that you're earning money for every lawn that you mow. Well, you're going to have $0 in your pocket before you mow any grass, so you're starting at 0, 0. But let's say you have money already in your account, and then you want to contribute to that account by adding more money for each lawn that you mow. That would not be direct variation because you already are starting with an initial value. Okay, so a review of the definition constant of variation, or technically we learned it as constant of proportionality in 6th grade. That's just the slope of a proportional relationship. They're going to use your k. To express a direct variation, we say that y varies directly as x, which means as x increases, y increases or decreases at a constant rate. So here's an example. If we have the equation y equals 3x, and we know that x equals 7, then y has to be 21. Likewise, if y varies directly with x, and y equals 21 when x is 7, we can create our equation y equals 3x. So this is what we've been using for years now, and this is how it's going to be phrased instead. It's kind of like we're working backwards. Y equals kx when y is 21 and x is 7. We can divide 7 to the other side to find our constant of 3. Y equals 3x. Okay, we're going to be comparing some variation, so that's what this next part's going to show you. If you know that y varies directly as x for one set of values, you can use a proportion to find the other set of corresponding values. So your book defines it using x1, y1, x2, y2. So if we have one equation that connects the x1 and y1, and we have a second equation that connects x2 and y2, and if I get k by itself, notice this is just slope. We said above, k is just a special type of slope, and we know slope is the change in y over x. Okay, so if they give you two ordered pairs, if you set them up as y over x, y over x, and we know that they directly vary, then we can just simply set up a proportion. If they are direct variation, their slopes have to be equal. Okay, so let's take a look at what we have on the next page with guided practice 1, and I do have a note written down here for you. Within proportions, both sides of the equation can be flipped and still be equal. So this might be helpful depending on what you're given. So we know if y over x equals y over x for two different equations, then x over y equals x over y for those same two equations. You can always flip proportions. That's what's nice about those. So guided practice 1, if they're going to kind of throw some other variables at you here, so you just want to make sure you use the terminology correctly. If r varies directly as t, and r equals negative 20 when t equals 4, find r when t equals negative 6. Well, we just said proportions can be flipped. As long as you keep that proportional relationship true by putting both y's either in the numerator or the denominator and the x's in the other location, truly does not matter which one you memorize as what is r the x or is t the x. So don't get caught up on that. Just set up your proportion. So I put my r's on top, my t's on bottom. And the reason why I did that is because I'm missing one of my r values, and it's a little bit simpler for me when my unknown number is on top. So I matched my negative 20 with my 4, because that's the correspondence with those 2 points. Sorry, those 2 values for that point. But I'm missing r when t is negative 6. So my unknown goes with negative 6. And then we just have a proportion, cross multiplication, or even shorter, negative 20 divided by 4 is negative 5. Multiply that by negative 6, we get 30. Okay, and here's another way you can think about it too. You can actually split them up into 2 separate fractions. Sorry, my son's coming over. Let me shift my stuff so he doesn't knock it off. Okay. And that's how you do direct variation. You just set up a proportion.